Hello, Dave Kenworthy here. Today we're going to look at some continuation work from a video I produced a while back about ancient cultures represented by the foot and pi in the Giza base. We use the Egyptian foot and that produces pi in the Giza base. And it's 11.666 inches, and we're going to carry on now with that. And we're going to produce a spreadsheet that analyzes this Egyptian foot. And what we're going to do is we're going to look at how Petrie's pavement level is positioned in the base 100 design using the Egyptian foot, and Petrie's measure over and above the very bottom base level of the pyramid below the pavement level is 5.333 Egyptian feet in height, and the Egyptian foot is 1.32, which is the lunar standard of Lagash, multiplied by 4 to give 5.28, then multiplied by 100 over 99 to give the base 100 unit that is used to give the elevation of the pavement over the base. And it's 62.222 inches. Not a surprise, because the Egyptians were using 10 over 9 as a unit, which is 1.111. And what we find is 1 unit in the Giza base is 100 digits in the base, and in the height it's 1 Egyptian foot of 15.9090 digits. The digit's 0.733, which is Berryman's Shusi of 0.66 times 10 over 9, and there's a 10 over 9 that I'm telling you about. So it gives us an Egyptian foot of 35 divided by 3 inches, and 35 is base 7 times 5. So the actual height of the pyramid is base 7 unit, and we know it's 280 cubits. So base 7 as a foot will work very nicely into 280 cubits. It gives us a Giza base of 73.333 inches, base side of 18.33 inches. So you've got to remember now, we're right at the top of the pyramid here. And the cubit, because we've got 1760 cubits in the Giza base, and we've got a base side of 18.33, we divide that by 440. We get a cubit of 0.041666 inches, which sounds ridiculous to people who are not really considering the full design of Giza. You've got to go right to the top of Giza. It's not just 1760 cubits in the base, it's 1760 cubits when only 1 unit is being used, so the cubit becomes very small. The other way to do it is keep a constant cubit and reduce the number of cubits in the base to the top. So there are 2 different ways to design the Giza pyramid, and in this presentation we're looking at the one where the number of cubits in the base stays the same, always 1760. Interestingly, when we use this unit of 5.28 times 100 over 99, we get 0.222 inches in the length of the cubit, which is 10 over 9 times 2. Sorry, it's 10 over 90 times 2. And the Earth's circle is 266.666 recurring units. And that's the number that we want to take off the full base 100 design of the Giza pyramid. So we go down in steps to the base of the pyramid. So when there are 100 units in the Giza pyramid, we get 10,000 digits in the base, and we go through these numbers again that we see up here because we're just multiplying out. And all we're doing now is multiplying this line by 2, 3 and 4, and then 5 to get to the top. And then when we get to the top, we get 366 as we're expecting, we get 5833.33 as we're expecting, using 44 over 7. We got the base 100 cubit in the design, and we get 25,000 miles in the eclipse model. So we take in 5.33 off 500 and we get this. And we know that Petrie gets 9068.8 inches. And what do we get using this? 9068.8. And then we've got this string of decimal places because they're using 10/9. So Petrie discovered that it was 9068.8. He discovered the cubit was 20.611, when in actual fact, if we're using Egyptian maths, these are extended decimal places. So Petrie got his measure. I don't know how he did it. I really couldn't tell you, but he got it absolutely correct. He's given a pavement Earth circumference of 24733.333 miles. 266.666 miles off 25,000. So we can see that this is a very well planned design using a unit of 11.666 inches. And what is it exactly? Berryman on page 14 of his book tells us exactly what's going on. And when I read this, I didn't figure out what he meant for a very long time, and then suddenly the penny dropped. Let's get a bit closer. I don't know if you can see that. I hope you can. He says, a peculiarity about the number k is that it can be expressed with negligible error by the ratio 35 divided by 27, which equals 1.296, and then two funny dots over the numbers. Decimal fraction recurring. Now mathematicians will understand that. It didn't mean anything to me when I saw it. Such ratios exist in ancient metrology, but their sexagesimal significance would not be apparent if their connection with k was unknown. So he's rating this unit k, and then he's extending it by making it 35/27. And there's 5 times 7 is 35, and 3 times 9 is 27. And there's a lot of metrology just in that fraction. And what we get in Berryman's book is a Roman foot. Oh, let me just talk about K. K is 1.296 inches as a standard, noting that 16 times 1.296 is 20.736. We talked about that in the previous video, John Neal's cubit. The Roman foot multiply is 0.729 as a digit, and that is 9/10 times 9/10 times 9/10 multiplied by 16. It gives 11.664, and this is what I was talking about in the previous video, using cubic units as straight line measure. That's a cubic unit, 9/10 times 9/10 times 9/10. And then we take it up to Egyptian. The Egyptian foot is 16 times 0.729166, and that's 11.666 using K as that number we've discussed. Difference between the two, 0.002666 multiplied by 2 is 0.005333, and that's where this is coming from. 2666 there, 24733 there, and the logic is absolutely apparent. And that's all I've got to say. Thank you.